So in this video we'll be looking at this design and creating some copper ground planes. Now ground planes are useful for various reasons. In this case this could be due to actually increasing the current flow through these devices, because these are motor controllers, so you can have higher powered motors being driven from this board. Okay, so the way, if you remember, we can look at the nets, and the nets show a GND, which is going to be our common ground, and when you do that it highlights all the connections with the GND symbol. Well, we want those, not only, we don't just want a big sheet of copper, we want these connections to be connected to the copper. So we do the routing as before, but then we create our copper on top of that. And the way we do that is with this menu up here called Drafting Tools, and then we have to go to this one called 2D Line. Now a 2D line is quite a good name. If we right click we can actually see a little pointer which looks like a drawing pencil. If we do right click we can change it to rectangle to save us having to draw circles or anything else, so rectangle. And then basically we're going to just construct a rectangle very close to the board edge. This is actually the board edge here. We're just going to have it just inside the board edge. And then we're going to do another one. This time we're going to do exactly the same again. 2D line, rectangle. This time we want to add one slightly further in. I'll explain why we need to do that in a minute. And so we've now got what looks like two yellow rectangles, but we're going to change the characteristics of these. And the way we do that is with Escape and then go to Shapes. 2D lines are classed as shapes. So if we click on the inner one, it comes up with the properties of this line and it says 2D line. But we can change that, and if we go down here it says copper pour. So in other words, we're going to pour copper all over this layer of the board, and this top layer is going to be the one we do it on. But we can also assign a net to it. So in other words, we're saying we don't want to just fill the board full of copper, we want to connect it to various named connections. And if we look under the list, we'll find the one we want, which is the ground net. So that's basically it. We're going to fill the top layer with grounds, with the connections. Now, it didn't appear to do it, okay, and it doesn't until you do. You've got to select the rectangle that you've just created, and then there's one called flood. So you've got these pouring and flooding, but basically flooding, if you say yes, is the thing that actually does the filling full of copper. So if we zoom in, we can see that it's anything that's actually connected on the copper, if you look here, is connected. So in other words, this is all blue, and you can see there's little blue connections going through. These are called thermal reliefs. They're not connecting this track to a solid copper, because if they did, you wouldn't be able to solder it, because heating this joint, all that heat would dissipate into this copper, so the temperature would not rise very far to be able to solder. So they have these little spokes, and thermal reliefs is their name, which reduces this likelihood that the heat will actually get through and escape through these little spokes. And so the temperature of the actual soldering iron will be high enough to be able to melt the insulation, the actual solder. And obviously anywhere where there's a track in existence that isn't ground, it puts this isolation. And isolation, which is really this gap, or clearance is their term. The clearance is the thing that we just want to talk about. The main problem with this is that this is too small. This clearance is too small, because when you come to try soldering that joint, you're only a quarter of a millimetre away from a ground. We've actually wired this blue area to ground. So all these connections are potentially very close to short circuit. So when you come to manufacture them and assemble them and solder them, you find that you get short circuits all over the place, and it's usually due to this gap. So if we do it again, we can actually just hit the delete key by selecting it and deleting. If we go back again, but before we do that, we change the clearance. And if we go up to the tools menu, no, got it wrong, the setup menu, design rules, default clearance, then we've got this thing called clearance here, and at the moment you can see that it's only 6. If we change that to 25 or something quite substantial, then basically when it comes to do the flood, it checks this parameter to say how close am I allowed to fill it. So now when we come to, we have to close all these windows, when we come to do the flood again, what we've got now is a very large area between the copper ground and the actual connections. So in fact that's much safer because you can now easily solder this without the solder running and shorting across the short circuits. We can also do the other layer. We've only done one side at the moment, but the reason if you remember, I did 2 rectangles, one inside the other, means that I can now access this one. So if I double click on that one, I can now change this one to a copper pour, and then say the bottom layer. So this time it will then, when we again do the flood, it will now flood that. Now we can't actually see it very well until we change the layer. So if we go from top being selected to bottom, we can now see we're looking at the bottom, and so the fill or the flood has actually done the top as well. Anywhere where there's a ground, we can see now this red bottom track is connected to the blue top track all the way through this hole and onto the copper. So both layers of copper are actually all connected together via these common points. And so you get a you're utilising as much copper as possible on both layers of the board to be able to create a very low noise system, very low noise design.